Okay, welcome everyone. We're having this talk about integrating computer vision and natural language processing for smart property tagging. We're having the speaker Oliver Lockett from Zoopla. Oliver is a data scientist at Zoopla, specializing in user personalization for the Zoopla marketplace. After securing his master's from UCL in 2021, he took his initial steps in data science with Culture Trip, a travel e-commerce company, before transitioning to Zoopla in 2022. Throughout his career, Oliver has been instrumental in harnessing user behavior data to develop influential predictive models, particularly emphasizing natural language processing (NLP) to refine user experiences. So can we give welcome Oliver to the stage? Thank you.
Cheers. Can everyone hear me? Oh, wow. Okay, great. Yeah, hi, I'm Ollie. Don't be confused by the Houseful logo. It's actually just our parent company name. It's just the slides I've got to use. But yes, I am from Zoopla. You're not in the wrong talk or anything like that. Yeah, I'm here to talk about our project, basically Smart Tags, which is looking at combining computer vision and the natural language processing to enhance our ability to actually tag properties, basically. Yeah, quick explainer. We're still Zoopla, but we just got a change of branding. That's why. Who are we? So me, hi, I'm Ollie, data scientist. Great introduction from me there. But then also we have our machine learning engineer, Will Martin, who, as you can see, is not here, but he has also contributed a lot to this project as well, and we've worked very closely on this. So I will be talking about the architectural side of it later on, which is kind of his work, so I'm just going to give credit to him now. And then, yeah, so crack on. Yeah, kind of I'm going to go through what issues we face, how smart tags we hope can help solve these issues, the data science approach, which is the stuff I've been doing, machine learning engineering approach, which is stuff Will's been doing, and then quick wrap up. So a lot to do, 20 minutes, so I'm going to crack on. So yeah, what is the actual problem we've actually been trying to solve? So like in the process of purchasing maybe your perfect home or even just an affordable rental property, it takes time, it's long, laborious, lots of moving parts. Not all of those are Zoopla's fault, but the part that we can help with is the actual searching element of that. So we're always thinking, how can we improve the search process so you don't have to go through hundreds of listings, thousands of images just to reach, maybe just find the basic threshold of a property that you're looking for. You're finishing at the end of the day, you just want to know that you're going for a viewing of a property with the open plan kitchen you've always wanted. So how can we simplify that discovering of property features and overall streamline the discovery process? We hope that the solution is the smart tags, or the smart pipeline in this case. So smart tags are a project that we're currently looking to roll out in the near future and hopefully provide semantic multimodal automated realty tagging. So what does that mean? Semantic in the fact that we're using models that are context aware, especially on the NLP side. We're using BERT models for the classifications. Multimodal, we're trying to pull from both images and text, the information. Automated, we want this running live. We want someone to post their property online and then instantly have those tags appear. Realty, real estate tagging. So basically, it's a machine learning inventory tagging system that uses the text and images given by sellers, identify a property has one of maybe a specified list of features or styles, and then list that information based on the analysis. So we did an analysis of the most searched keywords, basically. So hopefully the tags that we're presenting are the most useful or just surfacing what people really want for a listing. How can it best benefit our customers or consumers or users? Well, we can kind of look to our friends across the pond at Zillow and kind of look how they've implemented this already, or implemented very similar. So you can see that they've, in that sort of overview section, there's a few bubbles there. I don't know if you can see that, but there's like AC and that sort of thing. So you can kind of already see that someone might have a basic threshold. Instead of having to sift through all of that text, they can go, okay, this property has an AC, it has a pool, that's what I'm looking for from a property. I will continue to read. If it doesn't, you don't have to carry on reading. It's just streamlining that whole process. And you see on the right here, they've got the even in the little thumbnail for the carousels. And so just these key property attributes displayed up front for the listing, basically. that's benefiting our users, but how can that benefit us? We can build a much better data profile, especially if people are using these tags for search or using these tags to move around our site. We're able to analyze industry trends. All of a sudden, maybe Victorian properties are being sold a lot at the moment or something like that. That helps our research and insights team. And hopefully there's kind of like a follow-on effect that estate agents and house sellers kind of begin to give us better quality images, better descriptions, so we can build better models, more descriptive. So you can kind of see how it's kind of almost self-perpetuating. But how do we even get to this point? So yeah, first thing I did was to kind of investigate the data at our disposal and look at what sort of tags would be achievable. So first, looking at these images, you've got top left for you, yeah. You've got Victorian property, nice bay windows, a spacious living room, natural light. All of these seem to be in pretty good condition property. So you can already see the sort of tags that we can pull from the images. And then looking towards text, although kind of messy, but you can see that there's beginning to be some extra tags that you wouldn't be able to find from the images. So access to good schools, well connected, good storage, recently refurbished. These is kind of adds another layer on top of what the images can provide for us. So yeah, there's a lot of data points to play with, and that's a good start basically. So step 2 was building the taxonomy. So this is one of the most important processes because we need this to be durable. We're going to add loads of tags. We're going to deepen this taxonomy. So we need the actual groupings to be durable to that. And also helps us to identify where categories might be mutually exclusive or not mutually exclusive. So maybe, we see images, or that, if there's an image of a bath, it's definitely not a garden. So you might want to use different functions to make sure that we don't get contrasting or contradicting tags, basically. But yeah, so once we've built this or have an agreed taxonomy, basically, we can move on to the actual modeling side. So the approach we've taken is got that listing over there on the left. And then, so each listing will have about 10 to 15 images. Each of those will be passed into a computer vision multi-label classifier. So we'll get 15 outputs for each of the image, basically. This will be passed into an aggregator, so we're only kind of wanting to maybe know the max image. If it's a Victorian property, we want to see how many images were above a threshold or something like that. So we will have an aggregator function in there, which will then be passed over to our combination classifier. At the same time, we'll go have a look at the text. There's some important bits of the text, the bullet points, listing description, that sort of thing. This will be passed through to our multi-label NLP classifier model. For this, we've chosen to go with a BERT model, just for the context it gives us. We tried static embeddings with a classifier and even some regex, but our main issue is you just need that context in certain cases. One of those cases being Bath. So what we were finding was almost every property within the vicinity of Bath or in Bath were being tagged as having a bath, which not that helpful in the end. And yeah, there's others like hardwood floors. There's so many different ways of describing hardwood floors or wooden floors that we decided that a BERT-based model would going to be much more useful in this case, instead of having to type out every different way of saying hardwood floors. So yeah, so once those are combined in the combination classifier, we'll hopefully get these probabilities of each of the features that we're looking for, and then it's on us to apply certain thresholds, apply ranking algorithms, that sort of thing. So that kind of allows us to apply some personalization, especially with the ranking algorithms later on. This might be location-based, so if a property is by the seaside, we might want to rank certain tags based, sea view or ocean view or something like that to be much higher. Or, further down the line, full-on personalization based on your previous search history. So you can see what we've found most of the time is a lot of the information can be found directly from the text. And although the image kind of provides other added benefits, it's a nice addition to have. Why we've actually chosen to go with both the listing text and the images is often we find that people might miss out something about the property in the text. So say like a kitchen island. someone might really desperately want a kitchen island, we might be able to see that in the images. That's why we kind of used the combination of the two, because we found more often than not that they provided, they complemented each other very well. What we also find by using both text and images is we can identify when people are not being 100% truthful about a property. So you can see here from the listing text, I don't know if you can see the highlighted bits, but we can see, really good condition, this superb property, which, for the majority of those photos, they were. But then when we kind of look a bit deeper, you can see there's some so there's some property damage or somewhere that someone might need to be informed that maybe they want to. It might be a fixer-upper. So we can maybe highlight that to the person who's publishing the listing, or just applying a tag, maybe saying fixer-upper. But then, also we can, having a number of tags that require both the computer vision and the NLP to corroborate the facts allows us to kind of mitigate property sellers maybe trying to game the system. So just writing has a pool, but you're not putting an image of a pool, you're probably not going to have a pool, let's be honest. So it corroborates the facts and also kind of increases the confidence and in the reliability of our tags, basically. That's all the fun and games that I get to do, and then over to the actual hard stuff, which is what Will has been working on. So this is kind of the data lifecycle. This is the pipeline that we kind of want to see going on. So someone publishes a listing onto the Zoopla website, passes through the listings ingestion pipeline, in which there will be the tagging pipeline, database, straight away, detected tags straight back onto the website. So what are these sort of key things that we need, the requirements, basically? So we've got listing data is processed when published, should be displayed immediately, possible to update previous listings, so we want to enrich our previous data, must run quickly and cost effectively. So we clearly need it to be supported in real time, and batch processing to enrich our data. And then also we've been looking at optimizing the hardware available. So especially with the live side, we've got ARM hardware, using ARM compute library, more commonly known as ACL. And then with the batch, we're using custom AWS hardware for that deep learning, so using inferentia in that case. So the last diagram seemed fairly simple. So this is what we're actually sort of playing with at this stage. So we've got two entry points, as you can see. I'll start with my end, which is the data science side. That's the batch side. So I've been playing around. I've added a tag, whoop-de-woo. So then that would then get promoted and then run the smart tags distributed job, pull all of the listings from the listing store, and then run those jobs. These are then being parallelized horizontally, adding more instances, and also running on the inferentia hardware that I talked about previously, which has large compute capacity for compute. And then, so this reads the listing data and then stores it back into our sort of data smart tag store, which is the cache in this case. And then at live, we'll have a customer publishing a new listing, updating a new listing, something like that. Runs through the process listing pipeline. Then once it's in the listing store, we do a comparison with the cache. We check what model of the version that's being run and what sort of tags have been given to this. We check that with what we have in the cache. If that needs to be run again, we'll run at smart tags. We have the most up-to-date version of the tags in the cache. This is then read by the server and published on the website. So we've got these two, not competing, but asynchronous systems that need to synchronize with each other, basically. So we've got what are the sort of key challenges. So ensuring this synchronization works with the model updates as well. We need it to run fast and as cheaply as possible, so that's why we're running it through the specialized hardware. We're also having to test inference on the specialized hardware, so this is running our test data through the actual instances that run live. Not conventional, normally you'd run it through like a CI/CD pipeline, but because it's specialized hardware, we don't actually have that in the pipeline. So, and also, this new hardware, we've got a, chances of incorrect results, memory overload, that sort of thing. So it puts a lot of pressure or importance on our end-to-end testing, which must be able to account for all of this. So the diamond architecture, the multiple entry points, the one source of truth and the cache being correct. We need to all make sure it all works together and synchronization is ensured, basically. Yeah, okay, so just to wrap up, the challenges that we've come across. So finding the perfect property can be tedious, long. That's where we can come in, especially in the search side of it. Solution is the smart pipeline. Using the rich sources of data that we've got, we can identify and tag key aspects. The machine learning side, we're using context-aware models to kind of get around certain issues that we're having with actual tagging, but also using the NLP and the CV to not only corroborate results, but also to kind of extend any tags we might have missed. And then with the machine learning architecture, yeah, both supporting both live and batch processing and increasing, this leads to the increased importance of the end-to-end testing just with the new architectures and stuff like that. So that's it. Thank you. Yes. Oh, yeah. Go on.
When there's when the image
Mhm.
and the text doesn't match,
Yeah.
so how do you, process that? Do you look at how similar they both are, or do you give preference to, say, the image or the text?
So in that case, we'll probably give preference to the image because at the end of the day, if there is an image, if we can categorically say there's an image of a pool there, it's going to be way better than assuming that someone's written about a pool. But yeah, so at the end of the day, the images will be the final source of truth, although, like I said, there's some stuff that images can't show, like how connected it is to local transport links and stuff like that. So yeah.
So is it like a probability kind of a thing? So
Yeah, we might have some thresholds to be like, okay, this image we are sure this image is this, we're sure, but the text is not aligning with that. So the probability of the text being that will be below a certain threshold. So that's where.
Very good presentation, Oli.
Cheers.
My question is on your tags taxonomy.
Yes.
Do you have one, or like did you build it from scratch, or like?
Yeah. No. So yeah, what we did, we started off. Yeah, I probably should have said it. So we took like the most searched keywords, and then those were like basically the building blocks from there, and then as in, so yeah, it wasn't just a randomly selected group of words or something like that. But
And then
yeah.
when you scan for this, when you like use NLP under descriptions, does it like match on if a keyword in the description matches a tag in your taxonomy, then you apply that tag? Is that?
Yeah. So with the multi-label system, so like it's almost like we'll have it almost like an individual model for that certain tag. So hopefully it's not just the word, but like because we're using the context-aware stuff, there'll be words around it that will indicate. But yeah, roughly yes.
Thank you very much.
Sorry.
I think we still have one more question. Time for one. Who do you
Yeah,
choose?
anyone. Go for
No,
it.
don't leave the
There's-
choice for me.
Okay, that gentleman there, he's kept his hand up the longest, so.
Hi, thanks for the presentation. It was
Sure.
really good.
Cheers.
My question is, are there any particular industries that you look at for inspiration around your model, like either horizontal or vertical? So like maybe
Yeah.
comparison websites or...
Comparison websites. I mean, what we find is, the American companies like Zillow are often quite ahead of much of what's happening in Europe. So yeah, Zillow especially is, quite an inspirational website in terms of like what they're doing. But yeah, most consumer-facing websites, we're always trying to have a look at how they're optimizing to help those users, because what they've got, the learnings that they have, there's definitely translatable over to us. Although we're property, we can take stuff from what Amazon are doing as well. But yeah, if it was going to be like a specific company, it would be probably Zillow, who are doing a lot of what we should all be doing in our space, basically in the property portal space. Yeah.
Thank you.
All right, let's give him an applause. Thank you so much, Oliver.